Thank you for joining, everybody. This is Exploring Data Pipeline Runtimes with Elyra and JupyterLab at JupyterCon 2020. A little background about myself. My name is Alan. I'm a senior software engineer with the Code team here at IBM. I've been working with open source projects for about 4 years now, currently contributing to the Jupyter Enterprise Gateway project, as well as, of course, the Elyra AI project. Feel free to contact me. All my information is on this page. Questions, comments, concerns about anything in this presentation or our project. So a brief overview, what's in store. We're going to go over how to create a notebook-based pipeline, a little background behind it. Then we'll jump into Elyra's pipeline editor with a short demo and go into explaining our pipeline processor. So let's make a pipeline. So what is a pipeline? So we're going to start with the simplest, relatively speaking, example of a pipeline, which is a Python script. What you do is you'd read in some data, you do something with this data, and then you push the stuff you want to keep to a file system or an object store of some kind. You would probably leave this script running on a host system somewhere via cron job or some kind of scheduler. But why use Python scripts when we can use notebooks, right? I mean, this is Jupyter. Using notebooks makes things a lot easier to understand. It's more intuitive due to how they encompass units of work into these cells and how they can be run iteratively. Doing so makes it easier to tell a story behind the pipeline. With that said, these stories can grow big over time, much like a novel. What we want to do is we want to break them up into smaller chapters, in which case we'd want to break them up into smaller notebooks like so. Makes it easier in the long run to maintain as well. This also brings in with the benefit that if you were to run notebooks as a pipeline, if you have a notebook that doesn't have a dependency on a prior notebook for some sort of output, you'd be able to run them in parallel. Now, after you modularize your pipelines, some notebooks may have different requirements than others, like library frameworks, learning frameworks, as well as any miscellaneous application environmental configurations or variables. When we want to eventually make these pipelines shareable or portable, these factors need to be taken into account. And what we want to use is containers. They provide a nice, elegant solution to this problem. So it's a common pattern. You usually typically run workloads in containers via an entry point set to a script, and that takes in parameters. Pre-building these images with your libraries and frameworks in place is a huge time savings, as well as makes it consistent and reproducible, as well as isolated. Now, there was one thing I didn't talk about in previous slides, which was the hardware requirements here. So, like many deep learning workloads, you typically want to have more CPU and memory. You might be running with different architectures and, of course, ubiquitous GPUs and deep learning accelerators. These vary from workload to workload. So with that said, another elegant solution would be to use a container orchestrator to manage these resources. Workers can have different hardware configurations, and they can adapt to your workload needs. It can scale up and down depending on whether you need more resources like CPUs and TPUs and GPUs, a lot of use, or if you in a lull, like say during Christmas break, and you need to wind things down, you can bring the cluster down to a more manageable level. So in the end, your pipeline will end up looking something like this. So at this point, there are a lot of technologies in place, and the complexity can put people off pretty quickly, especially when they have to go to create this pipeline, especially when using some of the more popular workflow pipeline workflow orchestrators like Kubeflow, Airflow. Users need to spend time learning how to create these pipelines as code with the libraries or domain-specific languages that each of these runtimes uses. What Elyra is trying to solve is that problem itself. We want to make it as easy as possible for data engineers and scientists to be able to quickly prototype and run their pipelines without the need to learn this extra layer of code. So this is our Elyra launch page. We want to go and take a look at our Python editor. So we're going to go ahead and open up this pre-constructed pipeline that we have right here. This may look familiar from before. So typically what we want to do is we want to read in some data, do something with it, and we want to output and store. So we can configure on a per notebook basis these options here, runtime, image, file dependencies that we're going to go over in a little bit. We want to run that on a pre-configured, pre-deployed Kubeflow pipelines runtime right here. We're going to go ahead and submit that, and that's succeeded. And here's a look at what it's going to look like once we submit it to Kubeflow pipeline. So as you can see, did everything for us, constructed the pipeline. We're going to go over it step by step here in the next few slides. So as you may have noticed from the demo, each notebook or node is given the option of selecting what image you would like to use. You can, of course, add custom images to this list, as well as adding any local files that the notebook might need to run, adding environmental variables that need to be set within the container itself, and any available files that will be created by this notebook to any child-dependent notebook later down in the pipeline. All these parameters are passed to our pipeline processor, which are then used to create the pipeline. We have a processor base class that allows users to extend Elyra's pipeline processor to use different workflow orchestrators. So we have one for running locally with Kubeflow and one in progress with Airflow. This base class provides a couple of abstract methods to configure each of these containers to properly set environmental variables, resource allotments. For example, in our Kubeflow processor, we use a combination of Kubeflow, DSL, and Kubernetes libraries in the process method to get the behavior we want when running with Kubeflow. So here's an example of our Kubeflow pipelines processor and what it does. We first construct the graph of the pipeline using Kubeflow DSL, using the information that we get from the pipeline editor. We then upload any local files that we need for each of the pipelines, for each of the nodes in the pipeline, to an object store. We then compile this pipeline using the Kubeflow Pipelines SDK, and then we submit the compiled pipeline to Kubeflow Pipelines runtime endpoint, which then spawns containers based on the DSL that it receives. And then after every step, it pushes whatever intermediate artifacts it creates or that later child notebooks might need to S3. So something similar, if you were to implement Airflow, would be you would probably use the logic to create much in the same way, construct the DAG of the pipeline. And instead of submitting a compiled tar file, you would push the DAG to a DAG bag that's synced to that would use sync to Airflow. So this is a closer look at what happens inside each of the containers itself. So you'd submit the notebook, Papermill would then execute it, create an output notebook as well as any artifacts that are created. And then, like I said before, they're pushed to an object store. So wrapping up, what we'd want to do when creating a notebook-based pipeline, we'd want to deconstruct and modularize your existing pipeline into notebooks. we'd want to determine what our pipeline resource or resources and environmental requirements are. We'd build and run your notebook-based pipeline with Elyra's pipeline editor. If your favorite pipeline editor workflow isn't available, use our processor base class and extend it and add it. If you need any assistance with any of this, please don't hesitate to open an issue on our GitHub or just talk to us on Gitter. A few links on how to get involved. Please start and fork our repository if you're interested. Bug reports, anything that you might come across, please don't hesitate to open an issue. And here are a few of our other talks in JupyterCon 2020. And lastly, thank you for joining us, and stay safe and stay healthy. Thank you.